Question 8. A student experiments with low concentration hydrochloric acid, and they've given you a table here, some data. Complete the graph below by. So it's a complete the graph question. First of all, I've got to label the x-axis. So this is an interesting type of question because they've actually again nested all the questions together in one. So they don't tell me how many marks that's worth. They do tell me it's worth 4 marks overall. Okay, so I'm going to assume that the marks are going to 1, 1, and then maybe 2 for the last one. But they're 1 or 2 marks each. So first thing is I've got to label the x-axis. And if I look at the y-axis volume of gas in centimetres cubed, and I can see that's taken directly from here. Okay, exactly the same wording. Okay, there. Which means I'm pretty confident that the x-axis is going to be time in seconds. So time. So if I write just time like that, there's a chance I might not get the mark, because actually it's more than just time. Units are important. They've copied the table here exactly onto the axis label here. I would always recommend you do the same. So time in seconds. Okay, I know it might seem a little bit pedantic, but it's really worth not rushing, not panicking, and making sure you get that in as well. Next one, drawing a circle. So drawing a circle around the anomalous data point. Anomalous means it doesn't fit the pattern. Now, we're amazing at spotting patterns, humans. We can spot them in data. If you look through the data here, you'll be able to spot, hopefully, the pattern, the one that doesn't fit. But this is on the graph, we've got to do it. But you can probably spot straight away that goes up, okay. It looks like that one's wrong there. We're amazing at spotting patterns, especially in pictures. So if I told you that I was thinking of a shape, and I'm going to draw a shape here with crosses, I'm thinking of a shape, and pretty quickly you'll start to think, oh yeah, I think I know what that shape is, I'm hoping. Some of the crosses aren't exactly the right place, but I'm hoping anyway most of you sort of realise that looks like a triangle. If I then suddenly put a cross out here, that one just looks wrong, doesn't it? People don't like it. You probably don't like that one very much either, there. But that one's certainly wrong, and this would be my triangle here. Okay, but you get the idea. So if we look here, we're looking at the general pattern. Okay, where the point's going. Well, it's clear that that one doesn't fit. So we put a circle around it, and just like here, when you think about the shape that those is being sketched out, you ignore that one entirely. Okay, so we ignore anomalies. Draw an appropriate line of best fit. Okay, so the line of best fit's an interesting one, because we have slightly different views here, I think, to sort of maths sometimes, which can make it more confusing. So here's some things that we're not going to do. So line of best fit. Don't. So don't. 1, we don't do dot to dot. Okay, we don't do dot to dot generally in science. 2, don't force a straight line. On the front of this pack, on the very front page, there are 6 shapes of graphs that are the sort of usual shapes that we'd expect to see in science. Okay, the only one missing is the horizontal zero gradient line. Okay, but in general, if the graph slopes up, we'd expect either a straight line, or a slope like this with a decreasing gradient, decreasing rate, or we'd expect, if it's sloping up, an increasing rate, we expect it to look like that. So here I can see that that's obviously that shape there. So I'm not going to force a straight line, and I'm never going to just join the first and last points together, because that ruler line there doesn't look anything like the pattern that I'm making. And the way you sort of check that is think, right, well, if I was to put if there were points going to be in between these, where would they be? Well, I'm expecting they'd be around here. Some of them aren't exactly on those, but this is the shape I'm seeing. And we're all, I don't think, I've never met a student yet who can't sort of see the shape. And yet quite often students will draw a straight line from there to there. Okay, the line we draw is supposed to represent the shape the points are making. So the way we do that is, well, I'll show you in a moment actually, but one other thing we don't do, and I can't really think of a better explanation of what this is, but students seem to get it. Don't do horsetails, and by that I mean this shading technique that you sometimes get, where I'm going to draw a line, I'm going to draw it in this sort of bit by bit like that. Okay, try not to do that because, well, ultimately you won't get any marks for it. Okay, that's not a line, that's a series of lines, that's a shading. So when we draw a line of best fit, what we're going to do is we're going to try and use our muscle memory. We're going to practice doing it a few times over the top without touching the paper. You're going to use a pencil as well. I'm going to do it in pen just so you can see. I hope I get it right first time, but if I don't, cross that bridge if we come to it. In fact, you know what, I'm going to do one deliberately that's way out. There we go. So I've done one there, and I'm not happy with it at all. So I'm just going to make sure the examiner knows, whoever's marking, make sure they know that that's not the one I want. Okay, that's why if you do it in pencil, do it faintly. So I might even write ignore, mistake, not the right one, but I'm going to make sure there's no way they're going to use that line. Right, let's go again. So I'm going to go over this line a few times, over where I think the line lies pretty much. And once I'm happy, I'm just going to draw my line on. Turns out my line doesn't touch, sort of touches that one a little bit, the bottom of that one, but it doesn't cross through any points. You might have noticed I moved the page slightly just to get a better position to draw my line. And I'll try to do it in one smooth action, one smooth go. Right, part B. Describe the relationship between volume of gas and time. It's worth 2 marks. Okay. Now this is where we're already hopefully well away from the wrong answer. It goes up, then it goes flat. That's going to get you no marks. The way we always start these sentences is as x, and in this case x is time. As time increases, volume does what? So volume's on the y-axis. Does it increase or decrease? This is where I go back to imagining there's a little person walking up this here. They always start at the origin down here, and this person is walking up a hill in this case. So the height is increasing for certain. So as time increases, volume increases, and most students are happy with that notion. Okay, but that will only get 1 mark. To get the rest of the mark, you have to think about the steepness of this curve. Okay, what's happening to the steepness? Well, it starts off here. If you can imagine you are walking up this, or you're cycling up it, this hill is steep. So this is very, very steep here. Up here, it's not steep. So the steepness it's got less steep. The steepness has decreased. Okay, if you imagine you're walking along here, that's much easier than walking along this bit down here at the beginning. Now, what we do is we call steepness, in my mind, I think steepness. If you have done this yet in maths, you might call it gradient, but in science we also call it rate. Okay, so that word rate. So as time increases, volume increases with a decreasing steepness, because that makes sense to me, the decreasing steepness, but I'm not going to get a mark for that, so I'm going to put rate as well, steepness or rate. Okay, and that's how you write a perfect description of a relationship of any graph in science.